Hi guys, welcome to this video. This is the solution for the exercise that I gave you last week. I hope you did your best to solve it. I hope that you found the solution. If not, let's work it together. So I show you in this video how to solve that problem. And before doing that, let's recap a little what was the question. The question was if we swap the Magistus invocation with one Magistus var, what is the probability of making construct? And number two, is it better to do that or to keep 3 Magistus invocation and 2 Magistus var? So let's start from some numbers that we got in videos 5 and 6 that I told you were quite important to watch again. If you remember what we did, and I can write it here, for video number 5 and video number 6, we look at the out. So this is the version, let's call it version 1, that is 3 Magistus invocation and 2 Magistus var. So the old version, right? Remember what we did? We say, okay, if there is no hand trap, how many outs do we have for light, fusion, and Shaddoll monster? And if you remember, we got 20 outs, 19, and 22. And you can watch these in the videos 5 and 6. And these was equivalent to a probability of 88%, 86.3%, and finally 90.8%. Then we say, okay, what happens when we have hand traps? Then the light targets were 13, 9 fusion spell, and finally 18 Shaddoll. And what is the probability associated with this? Well, 71.9%. 57% and 84.4%. Okay, then what we did was the multiplication of these numbers. Okay, so we got 69%, and here we got 34.6%. So this was what? This was the probability of construct, an approximation, given no hand trap, and this was the probability of construct given hand trap. Okay, then we use these numbers to compute the formula that is the probability of construct is this guy times probability of no hand trap times this guy probability of hand trap. So I can write it here. And this is nothing new. This is just the recap of what we did last time. So let's do this. So the formula was, if you remember, P of construct is equal to the probability of construct given no hand trap times the probability of no hand trap plus, and I write it here, the probability of construct if we have hand trap times probability of hand trap. And you remember, we also computed in the past these two guys here, right? So if you remember from the video, what was the probability of having hand trap? It was 57.7%, assuming that opponent is playing 6 hand traps, and this was 42.3%. So then this number here, right? This guy here is this guy here, and this guy here is this guy here, right? So here, for this version 1, what was the conclusion from the video? The conclusion was that, let's write it in red. So for version 1, actually, so for version 1, the probability of constructs, if you compute this formula, was equal to, do you remember? It was 49.2%. So this is nothing new. This was the previous stuff. Okay, let's look now at the new version. So let's call it, okay, here we can say, okay, this was the past. What about version 2? Version 2 means these times version 2 means 2 Magistus invocation and 3 Magistus ver. Okay, so we have 3 monsters and 2 spells. Okay, let's do the same kind of computation. When we have no hand trap and when we have hand trap. Okay, so how many lights, how many fusion, and how many shadows. Light targets. Okay, think about that. We remove 1 spell, but we got a new light monster. So we have 1 more, right? Now we have 21. Fusion is the same because, okay, here is no hand trap, right? So what we did, we lost 1 spell, but we got 1 monster that can allow us to get a spell. So the number is the same. And Shaddoll, there is not really a difference. So what are the probabilities? Let's do it later. But what about the outs when we have hand trap? Okay, light targets, we have 1 more because we have 1 monster, so it's 14. What about the fusions? Now, because Magistus Invocation is a spell that, you know, if we have in hands, it's fine. But Magistus Ver can be blocked by Ash and Gamma. This means that we lost 1 out. So instead of 9, when we have opponent with hand traps, we are going to 8. And for Shaddoll, well, that is the same number, right? 18. So the probability here is again 86.3. Let's write those who are the same. 18 is 84.4. This is different, right? So we need to compute 21, 8, and 14. And to do that, what we are going to do, well, we use the hypergeometry calculator. So 8, 14, and 21. Let's see. Deck of how many cards? Deck of 60 cards, right? Let's try with 8, 5, 1. So what do we get? So with 8 we have 52.4. Okay? So let's write it here. 52.4%. What about 14? Well, if we have 14, then the result is 74.9. Okay? 74.9. And finally 21 is 89.5. Okay? And what are the differences between the previous one and this one? So if you see, the difference was here. We have 1 light more. Here, we have 1 light more. And here, we have 1 fusion less. And you may be wondering, well, the intuition is that because I'm improving here and also here, I should get a better version 2, right, compared to version 1. Maybe no. Let's do the math. So what we have to do now is to multiply these three numbers, right? To get the probability of making construct if no hand trap. And of course you can expect it to be larger because now we are having one additional out. So how do we do that? We use our calculator and then we multiply the three numbers. So here we have the 89.5% times 86.3 times 90.8, and we got 70.1. 70.1. And of course this guy is larger than this guy, right? So this is the first number we need. What about this guy? Well, now is interesting because you see, the problem is that here we improve a little because when we have many outs, an additional out is just increasing a little the percentage. But here, see, 9 to 8, we lost like 5%, around 5%. That is big. So let's see what is the impact. We multiply these three numbers and we get this value. Let's go here. We do the multiplication and we see. So 74.9 times 52.4 times 84.4 and 33.1. Okay, 33.1. See here, it was 34, now it's 33. So we have to compare this guy with this guy, right? And what is the first observation you can make here is that this new version actually help us improve the probability of making construct if there is no hand trap by 1%, around 1%. But we lost 1.5% probability of making construct if opponent has got hand trap. And because the probability of having hand trap is larger than that of not having hand trap, then you can expect this guy to be worse. But let's compute it. So if you use this formula, what is the probability of construct here? Is 70.1%, right, times 42.3% plus 33.1 times 57.7, and this is equal to, let's do the calculation so we get our answer. So again, what do we have to do? Well, 70.1 times 42.3 plus 33.1 times 57.7. And then we got 48.8. We can approximate with that. 48.8, that is lower than this guy. This is the answer. The first version of the deck gave us a probability of making construct of 49.2. This guy here is 48.8. That means we are losing 0.4%. Well, it's not much. True, it's not much. But it's only one card out of 60. And even if it's not much, we know now that given the situation we are dealing with, so 6 entrap and the objective of making construct, this version 1 is better. So we should run 2 monsters and 3 spells instead of 2 spells and 3 monsters. But many people, I'm sure, would have said, oh no, we should run 3 monsters because if we have 3 spells, it can be a brick, then you have those in your hand, it's too many. No. No. Because the fusion is the limiting factor. Look here, the lowest number is the fusion cards. Actually, this is what we should improve. And this is something that you can consider when you want to try different variation. Always try to increase the number of that. And if you have to replace something, take from the largest numbers, right? Because when you remove one out from 21 to 20, see, we are losing 1.5%, moving from this to that. But look, when we move 9 to 8, we are losing like 5%. So the impact of removing one out in this case, because the number is so low, is much larger than the impact we got when we add one out from 20 to 21. Combined with the fact that the probability of opponent having hand trap is more than 50%, right? This drop that we got here is much more important than the 1% we gain here. So what is the summary of this? The summary is, number one, don't think that a solution you feel is intuitive is actually correct. You have now a procedure to know what is the best thing to do. Okay? And the procedure, again, I want to quickly recap. You count the outs if no hand trap. You count the outs if hand trap. You use the hypergeometric calculator to compute the probability, multiply the probability, then you apply this formula where you use the numbers you just found here, and you multiply by probability of no hand trap and hand trap respectively. And then you see that this deck is better because the probability of making construct here is larger than the probability of making construct here. So I really hope that this video clarified your doubts if you have. I also hope that some of you were able, hopefully the vast majority of people who tried that was able to get this solution. And if so, it means that you understood. Okay, so congratulations to you. For those of you who found this hard and even now they think it's not really clear, just watch it again, do the steps slowly, and if again there is any doubts, just let me know in the comments. Don't feel shy, I'm here to help you. This video is made for you to improve. It's not made for me. Like, this stuff I spent quite a lot of time to make it, and the real purpose is that I want to help as many people as possible to get a more systematic and precise approach to deck building rather than following advices of people that just say things because they think they make sense, but actually they don't make sense when you're looking at the numbers. Okay? So with that, I think I can conclude the video now. There will be maybe a couple of more videos for this series to conclude, and then after that, probably, I'm already thinking actually at this Mathematics of Deck Building 202. So an advanced series where we are going even more into the details, having even more precise formula, and doing some crazy stuff that you may not have seen anywhere else. At least I've not seen anywhere else. And I'm pretty sure that nobody did that before. So with that, thank you again. If you like the video, you know what to do, right? Like, share, comment, and really, again, if you have any questions, don't be shy. Just write me. Like, I'm not here to judge anyone. I'm here to help. Right, so I think it's very important if you really get this right, because as I said in the previous video, if you learn this, then you can apply to your deck and then you can improve your results. 0.4 may not be a big difference, but in the long term, if you take better decision mathematically, you are going to win more. It's like the casino. You know, the casino, when you play the roulette, they don't have a big edge over you, right? It's just because they have that green number, they are able to make a lot of money. Because this small percentage that they have, like the winning they can make is maybe, I don't remember exactly the number, but it's really something like 51-49, a very small difference, but that is enough for them to make millions of dollars. So it may not seem a big difference, but if you keep doing this kind of, but if you keep using decks that are better in terms of probability of winning, you're going to win more. You know, it's the same thing that happens in poker, at the casino, and so on. Okay? So with that, I really conclude. Thank you again, and see you at the next video.